Hello and welcome to the rules of indices, where you can use laws of indices to simplify powers of the same base. This will be our first topic of chapter Algebraic expressions. What does that mean? Basically, if we got the same base and the power, what that means is if we have the same base of a and different powers of n and m, or the same powers of m and n, we can plus the powers together. So what happens is that if we got the same base, like 7 power 2 times 7 power 3, if we got the same base, we can deal with the powers. So base stays the same and the powers plus together, so give us 7 power 5. And the same goes for multiplication, division. So a power n divided by a power m is going to be a n minus m, meaning that if you got the same bases, you can minus the powers because you're dividing the bases, and that gives us n minus m. So for example, 8 to the power of 11 divided by 8 to the power of 2 is the same as saying 8 to the power of 11 minus 2, which is 8 power 9. This is because we got the same bases and we got the division, which means we minus the powers of the same bases. There's a third rule, which is a power m to o to the power n, which is a m n. So whenever we got a power outside, we multiply by each term, each power by a power, and each term by the power n. So for example, if we got d, e, f power 2 or power n, then we just apply it to every term that's inside. For example here, 3 a b squared all to the power of 4. So what happens is that 3 gets to the power of 4, a gets to the power of 4, and b gets to the power of 4, but because it's squared, we have to multiply it together. 2 multiplied by 4 is 8, using the third rule of indices. So here they are, 4 rules of indices, and we're going to use them to solve some questions. Let's simplify these expressions. So we got x squared multiplied by x power 5. Okay, how do we tackle this question? It's very simple. We use the laws of indices. Why? Because we got the same base x and x with different powers, and we keep the base and we add on the powers, which is x power 7. Now what happens when we have numbers and letters together? We do the same as we would in normal multiplication. So bases are and another base r. So what that means is that 2 gets multiplied by 3, which is 6, and r squared times r cubed are getting multiplied separately. So we have like kind of 2 parts to the equation. We got the normal numbers, 2 times 3, which is 6, and we got r squared times r cubed, which means that we add powers together of r, and we get 6r to the power of 5. Now for the third question, b power 7 over b power 4 is the same as saying b power 7 divided by b power 4, because the fractions mean division. So b power 7 divided by b power 4 can be done by division rule, which in the corner we see that it's a to the power of n divided by a power m equals to a to the power of n minus m. So we're going to have b, because bases are the same, and we're going to minus the powers. So b power 3. Now, the question D. 6x power 5 divided by 3x power 3 is going to be divided. This is going to be the division rule. So we have the same basis of x, and what we do is we do the calculation first on the normal numbers. So 6 times 3 divided by 3, which is 2, and then we proceed with x power 5 divided by x power 3, which is x power 2. We negate the powers, so 5 minus 3 is 2. Now, 2 more questions before we go to expanding brackets and dealing with fractions. So, a power 3 all power 2 multiplied by 2a squared. Now we're using BIDMAS or BODMAS, whoever likes, and we're going to use the brackets first. So we're going to work out the brackets first, which is the third rule here, and that means that we're going to multiply the powers to get a power 6 multiplied by 2a squared. Now we multiply the normal numbers, so there's like a 1 in front of a, it's just 1a to the power 6, and we multiply 1 and 2 to get 2. And now we multiply the indices, so a power 8, because 6 plus 2 is 8. Now we got the last question. We do the brackets first, so that's 3 power 3 and x to the power of 2 multiplied by 3. We divide that by x to the power of 4. What happens here is we multiply each term by the power of 3. And what happens, we use the third rule and the fourth rule, which are here. And what happens here is we're going to now simplify this more by 3 power 3 is going to be 3 multiplied by 3 multiplied by 3, which is 27, and x power 6 divided by x power 4. So now we're going to divide the normal numbers, so 27 divided by 1 is 27, and x power 6 divided by x power 4 is x 6 minus 4, that is going to be 27x squared. Now that's a question you can try, and once you tried it, please unpause the video. Okay, so we got 2a to the power of 3 divided by 3a to the power of 2 multiplied by 6a to the power of 5, and we did them in order because it doesn't matter. Division and multiplication in BODMAS do not matter which way we do it. We have to do it from the left hand side by the order. So 2 divided by 3 is 2 over 3. Why? Because the basis of the front numbers is 2 divided by 3. And now we're dealing with a cubed divided by a squared, which is 3 minus 2, so a power 1. But we can just write a. And now we multiply this by 6a to the power 5. So what happens is 2 multiplied by 3, no, 2 multiplied by 6 divided by 3 is 4. Why? Because 2 over 3 multiplied by 6, like normal multiplication first, and then we deal with a and a to the power 5. So a multiplied by a to the power 5 is going to be the same as a to the power of 5 plus 1, which is a power 6. So the key to know from this chapter are to know the 4 rows of indices and know that the bottom one is called a base and the top one is called the exponent, index, or power. We come to exponents in chapter 14, but basically this is index, power, or exponent. Now we go to brackets. We're going to have the first question, which is minus 3x, 7x minus 4. So we use laws of indices. But how do we expand brackets? Basically what happens is we multiply minus 3x by every term in a bracket. And this happens by making minus 3x multiplied by 7x and adding minus 3x multiplying by minus 4. And now we use rows of indices to do this. So what happens here is we multiply minus 3x by 7x. That gives us minus 21x squared, because minus 3 times 7 is minus 21, and x times x is the same as x to the power of 1 times x to the power of 1, which is 1 plus 1 is 2, so power of the x is 2. And now we do the second part, where minus 3x gets multiplied by minus 4, and minus 3 times minus 4 is plus 12. And now there is nothing to multiply with x's, we just leave the x. So it's minus 21x squared plus 12x. Let's go to question B. What happens here? We get y squared and 3 minus 2y cubed. We do the same. We multiply y squared by each term in the bracket. So that's going to be 3 times y squared and plus y squared minus 2y cubed times minus 2y cubed. So what happens here is 3 times y squared is just 3y squared, and then y squared times minus 2y cubed is going to give us minus 2, because 1 times minus 2 is minus 2, and y squared times y cubed is going to be the same as y to the power of 3 plus 2, which is y to the power of 5. Next question. For x, 3x minus 2x squared plus 5x cubed. What happens here is we just multiply more. It's the same concept. We multiply the thing outside of the brackets to every part in the brackets. So that's going to be 4x times 3x plus 4x times minus 2x squared plus 4x times 5x cubed. So 4x times 3x, first we multiply the normal numbers 4 and 3 to give us 12. Now we multiply x and x to give us x squared. Now we do the same with the rest. Plus 4 multiplied by minus 2 is going to be minus 8, and then x cubed, because x power 1 times x power 2 is going to be x cubed. And now the last one, we have 4 multiplied by 5, which is 20, and then x multiplied by x cubed is going to be x power 4. Now that's it, and that is the answer. Basically, what happens sometimes is you can have the same like terms. So what do I mean by like terms? You're gonna see in a second. So what happens here, we multiply each term by 2x, and here each term by minus 5. So 2x times 5x plus 2x times 3 plus minus 5 multiplied by 2x plus minus 5 multiplied by 3. And what we get is 10x squared plus 6x minus 10x minus 15. And how did I get that? Because it's still examples. So 2 multiplied by 5 is 10. X times x is x squared. So that's how I get multiplied the first expression. Now we multiply 2x by 3. So 2 times 3 is going to be 6, and x on its own. So we just leave x there. So 2 times 3 is 6, and 6 times x is 6x, so it's 6x. Now we plus the minus 5 to x. So minus 5 times 2x is minus 5 times the 2, which is minus 10x, because x is just on its own, so it's just minus 10x. And now minus 5 times 3, we know how to do this, it's minus 15. Now we need to collect the like terms. Now what do I mean by like terms? So basically 7 plus 6 can be added together, which is 13. They like each other. Now x squared, 7x squared plus 6 cannot be added together because they're not the same. They don't like each other. They don't like each other. And what happens is that if you have 7x squared and 6x squared, you can get it to be 13 because they got the same x squared and they like each other. And here they do not have the same x squared. This one has x power 0, like imaginary x power 0, which is not the same family of x squared. So what happens here is that we have 6x and we got minus 10x. X's are the same. That means that we can minus each other 6x minus 10x, which gives us minus 4x. And the rest stays the same. And we don't modify it because x squared doesn't have any friend, x doesn't have any friend, and minus 15 doesn't have any friend. If there was plus 4x squared, then x squared would have a friend, and they would need to be added together to get minus 14x squared. And if minus 15 had a partner like plus 4, then we would have to add them together. But since they all don't have friends, they stay separate. Now we're going to do the exercise question, and I want you to do it on your own, and when you finish, unpause the video and we do it together. Okay, so what happens in here? We don't have any number in front of the bracket. there is imaginary 1 in front of the bracket. Imagine there was 1. So what happens? We multiply each term by 1 here to get r squared plus 3t squared plus 9. So this part stays the same. And now, negative 2r squared plus 3t squared minus 4. There's imaginary 1 here, so what happens is minus 1 is getting multiplied by all the terms in the brackets. So that's going to be minus 1 times 2r squared plus minus 1 times 3t squared plus minus 1 times minus 4. So r squared plus 3t squared plus 9 minus 2r squared minus 3t squared plus 4. So now we need to collect the like terms. So r squared and r squared like together, 3t squared and minus 3t squared, because they got t squared in it, they are like each other as well. And normal numbers without any r's or t's or x's are just family of each other as well. So they like each other too. And what happens is you do r squared minus 2r squared, which is minus r squared. Now we do plus 3t squared minus 3t squared, which is 0, and 9 plus 4, which is 13. Now there is just last more thing to do in this topic. So one more thing to know is when you have the expression at the top of the denominator, the numerator, and the denominator is x cubed. What happens is all the terms on the top gets divided by the bottom. So basically, x power 7 is getting divided by x cubed, and this part, x to the power 4, is getting divided by x cubed as well, to give us x power 4 plus x. Simple. The same goes with the second question. 3x squared minus 6x to the power 5 is going to be 2 divided by 2x. So every term 3x squared gets divided by 2x. That will be 3 over 2x, and minus 6x to the power 5 divided by 2x is going to be minus 3 to the power of x4. Okay. And that is it. Oh wait, it's not. We have question C. So 20x power 7 plus 15x power 3 is going to be divided by the 5x squared. So the same applies here. We divide this by this and this by this. So 20x to the power of 7 divided by 5x squared is going to be 4x power 5. And plus 15x cubed is going to be 15 divided by 5, which is 3, x cubed divided by x squared, which is x. And that is it. You can now go and do exercise 1a, which I explained all about. So you shouldn't have any problem given the examples. And the next topic will be expanding brackets, where x plus 5 will be multiplied by each term of another.